Hey guys, welcome back to my channel. This video I'm going to talk about another topic related to the AI bottleneck. Recently NVIDIA's variant grouping platform is now bringing CPO, the Cool Package Optics, into their production. So that sounds like a small network detail, but I think it points to something really bigger and you need to focus, which is that AI is starting to hit the physical limits of moving data with electricity. So this episode is not about talking about the optical stuff. So I'm going to help you to understand why AI optics or the optic module and the CPO really matter. If GPU are the brain of an AI factory, so optical interconnect is like the nervous system. So that's the reason why you have to pay attention to this kind of topic. So we can think of GPU are the machine, and the AI data center is more like a factory. So each machine can work incredibly fast, right? But the machine only create value if part move between them quickly, right? So if the conveyor belts are too slow, the machine will sit idle, right? You do not want your most expensive GPU to be idle, right? You would like to make sure your GPU working 24/7. And this is what happens in a GPU cluster. So a single GPU is really powerful, but a cluster is only powerful if the GPU constantly exchange data. Because when we use ChatGPT, when we use Cloud Code, when you use this kind of AI agent, when they output each one token, this GPU behind in the data center, they have to talk to each other, and the data it must fit this GPU fast enough to make sure that they can inference fast enough. Okay, let's continue. So copper is not bad because right now people still use copper to interconnect those kind of GPU, and copper is really excellent nearby. But as the speed and the distance rise, the electrical signal run into physical limits. So there are some problems you have to measure. The first one is like the signal loss, right? The signal can arrive distorted. And the second problem is the heat and power. So high-speed copper, they will burst more watts per bit. That's one problem, right? And the third one is timing distortion. What is that? It's like the zero, for the computer, what they have to understand is 0 and 1, right? So based on this scenario, zeros and ones become harder to separate because of the heat, power, distance issue. And the last one is signal integrity. That is materials, layout, and noise matters more. So overall, this is not just a software problem, it's more like a physics, right? The larger the AI factory gets, the harder it becomes to move everything with electricity alone. That is why you have to find another solution to solve what copper have, right? So when people say AI optics, they do not mean lightning. They mean using light as a data carrier, right? So optics, they use light just as a data carrier. So electricity carries zeros and ones through copper, and light carries zeros and ones through fiber. Okay, and fiber, what's the chat of fiber? Is that fiber can move data farther, right? And they can bring this data with higher bandwidth and with lower loss and lacks inference, right? So the core question become very simple. Chip speak electricity, but fiber carries lights. So how do you translate between two? So optical module here is very simple. So you can just that's just a translator. That translator is optical module. Yeah, the core question is to solve how to communicate and how to transmit from electricity and the lightning. So the chips, right? They send an electrical signal into the module, right? And the module turn it into lights and send it through fiber, right? And on the other side, you need a receiver. Another module, they receive the light and turn it back into the electricity, and then your chip can understand it. So the simplest way to say is like the chip speak electricity and the fiber carry light, and the optical module they translate. So this is the basic building block of the AI optics story right now. And then we have to talk about what is inside the optical module. I think there are 3 jobs, right? So the first one is transmit. So driver, they boost the electrical signal. And the modulator, they rise the zeros and ones into lights. And the laser here, they provide the light source. And the second one is receive, right? Because you here's a fiber out and the fiber in, that is received. So photodiode, they detect the lights. Okay, they sense that okay, here's light, and the TIA amplify the tiny electrical current, right? And the third one is repair, because there is some distortion, right? And the DSP and the CDR, the chip, they clean the distorted high-speed signal and they recover the timing. So I think we should not overcomplicate. The module is like a translation box. Yeah, the core question is like electricity and light. How do you transmit? How do you translate? And that's it. That's the core part. So let's talk about some history. Some history. Traditional optical modules are usually pluggable, right? They set at the front panel of a switch, and you can plug them in, remove them, and replace them. So that's the history, and that's people do in the past like 15 or 20 years. So that is why 800 gig and 1.6 terabyte pluggable optics are very important right now. But the hidden problem is distance inside the box. The switch ASIC, they sit inside the system, like you can see here, right? This is the pluggable, right? And the pluggable modules, they sit at the front panel. So between them is between them is like here is a high-speed electrical path across the PCB, right? You can see here, if you like to transmit something, you have to send through electrical path across the PCB. So here's a problem, right? Maybe some signal loss. Maybe you should care about the DSP's power and stuff like that. So because of it, more and more people and in the industrial, they talk about the CPO, because pluggable. This one, the pluggable optics can be strong in the near term, but still there is some structural limit in the long term, right? Because here you can fully understand that, and so in order to solve this kind of problem, so move up optical conversation. So the solution is very easy. So you have to put the optical conversation closer to the switch ASIC, right? That's the solution. In order to fix the problem because of the long electrical path. So for the CPO, so regarding the CPO, the ASIC, they got a sharp electrical path. You can see here, and they still got optical engine. So CPO is not just a faster optical module; it's like the chain of the structure, right? And this is a change for the optical conversation happen. So the goal here is like lower loss, lower power, and higher bandwidth density. That is the goal. And then we can see some different kind of, like you can see here is like the LPO, MPO, and the CPO. So what is LPO? You can see here LPO just keep the pluggable measure, but they reduce DSP power. So they're less power, right? And the second one is MPO. So MPO, they move the optics closer to the ASIC on the wall. And the CPO, like the future solution, is the CPO. So the direction is pretty clear. Keep the module, but you have to reduce power, and then you have to move the optics closer to the chip, and then package the optics with the chip. So there are more advanced idea in the like the optical I/O or the optical circuit switching, but we will not talk that in this episode, because in the next 3 or 5 years, CPO is the main character. Okay. And then we are going to talk about again our investment framework right now is like which company you are going to invest. So we have to follow our framework. So our framework is like the first, or the bottleneck, is like the AI commercialization, and the second one you have to focus on the hyperscalers capacity, and after that is the physical bottleneck. What is the bottleneck? We focus on this kind of bottleneck, and then we will focus on like the order, how is those companies' revenue, how about their margin, and what is the market's expectation right now. And that is our whole framework. And then so in the next episode, in the next few episodes, I'm going to talk about like 3 names and 3 companies I really focus, and I think they have great potential in this sector. The first one is Lumentum, LITE. So Lumentum is, I think they are like the upstream photonics bottleneck, because the lasers and the optical subsystem is very close to the heart of this kind of stack. And the second one is AAIO, because they are more of the near-term solution, because as I said before, 800G and 1.6T pluggable optics, right, is still very important right now. And the second thing is they are like the only US supply chain, like they are the only player here. So we have to focus on this company. And the third one is SIVE. So this one is more like an early like the silicon photonics option. They are very small company. They are less financial verified, but I think it's very interesting because of the laser. Because laser is very important in this kind of sector, and I think in the future it will become more and more important. So these are the 3 companies I will focus, and I will talk about that maybe in the next few episodes. So overall, optical interconnect is still often framed as a transceiver cycle, and I think that is too narrow. The deeper shape is that AI factories right now are turning the data movement into a core infrastructure bottleneck. So AI started as a compute story, then it became like a power story. Now it's becoming a data movement story. That's it. That's today's video, and I'm going to talk about those 3 companies in the next few video. And I hope you understand the sector, through my video today. If you like this kind of video, please subscribe and like.